Okay, I think we're to the point where we can talk about some more interesting numbers. The numbers that we always hear about, just for a recap, I guess, are the parts per million, 400-ish parts per million in the atmosphere. We hear about something that's going to happen if we double the concentration. Basically, there's speculation as to how much the temperature will rise, anywhere between a degree and 7 or 8 degrees. A lot of times the units of measure actually are left off on that, so I'm just going to keep up with that one. So you hear about those, maybe a few others. But what do you really need to know if you want to kind of wrap your mind around what's going on in the atmosphere? I realized as I was thinking about this that I really wanted to know how much CO2 is up there, how much we're putting up there, and, well, I guess those two things first. One of the reasons was that I really wanted to know what would happen if we, slowed our production of CO2. And how are we going to do that if we don't know how much is already up there and how much we're producing? So, do a little Googling. This first number was actually a little bit hard to find. It asks kind of a specific question to Google, and that is how much is in the atmosphere. I thought it was kind of weird. I guess it is talked about, and I've probably heard it before, but there are around a little over 3,000 gigatons in the atmosphere of CO2. Mankind is putting about, or emitting anywhere between 20 and 30 gigatons per year into the atmosphere due to burning fossil fuels. So if you do a little simple math here and just divide 30 into 300, that's where you get that century number. That if we keep on our current pace, the amount of CO2 in the atmosphere is going to double in a century. The thing is that we don't actually know if all the CO2 is staying in the atmosphere. We know it's actually not. I'm not actually sure how you measure this or how you know this. Actually, I haven't looked into that at all. Just the fact that it's not all staying up there. So some people say that only half is staying in the atmosphere. I'm sure there's as many opinions on this as there are people looking at it. But let's just say that not all of it is staying in the atmosphere. So if that's true, when you go back to that century number, it's going to stretch it out longer than a century. To stretch out longer than a century, the time it takes for us to double the amount in the atmosphere. So, I think this is one of the reasons why one of the sides in this debate is less urgent. They push back on AOC's 12-year number. I'm not sure if she was joking about that or not. She said she was, I guess. And then Al Gore's predictions about the sea level rises and all that kind of thing. So anyhow, that's one of the reasons why one of the sides is less urgent about things. So okay, and we'll probably revisit this later. Another number that I came across that I didn't know. I had definitely heard this before, but what is the percentage of CO2 in the atmosphere? We hear about it all the time, and the CO2 is used as the sole reason that the climate is changing. But how much is actually, what's the percentage? Turns out it's a trace gas. It's it's a little under 0.04%, which I was very surprised at. I had heard that before, and everybody knows that nitrogen and oxygen make up the majority of the atmosphere. But I didn't know that CO2 is that small of a percent of the overall atmosphere, which I thought was interesting. And this number will play out later. So, okay. I think those are the important numbers that I want to focus on right now. We'll come across some more, of course. But did you know them? Had you heard them? Do you hear them emphasized at all? I don't hear those numbers emphasized, just that we need to stop putting CO2 in the atmosphere. And I do hear that with the climate, the Paris Accord, even the amount that we would say be curbing our production wouldn't affect things much. And I think this is why. It's because that 20 or 30 gigatons per year is just it's even at that, and it's a ton of carbon, no pun intended. But it's just not that huge of a percentage of the 3,000. So anyhow, for what it's worth, I'm sure there's people that are probably screaming at the screen right now. Tell me why I'm wrong, but let's start there. I think those are some good numbers, and I think we can build upon them.